Hey guys, Rudi back with part 2 of the week 11 recursion tutorial for CSSE1001 and 7030. So in part 1 we had a bit of more in-depth look at what recursion really is, how it can work with some really sort of simple cases like this add and this minimum function. And now we're going to move on and look at the debugging and the files and folders example we've got here. Okay, so debugging recursive function. The following function aims to find the sum of a list, but does not always work. Determine why and modify the function definition to fix this error. Okay, so we've got this add to. Well, let's just try. Let's see what we get. 1, 2, wait, no, sorry. Oh, where's my mouse gone? Cool, we need a list. 1, 2, 3, 4. Cool, well that's a whole bunch of errors. So let's go back to the drawing board and see what we've got here. Slice indices must be integers or none or have an index method. Okay, so if we remember what slicing is this guy here, right? When we have a list or a string and we chuck some of these guys on the end of it with some colons to sort of reduce our list or filter our list almost as we go. Okay, so if we see what's happening here, let's kind of have a look at what the algorithm is trying to do. So with recursion, right, we've got our base case here. If our list is empty, return 0. Okay, that seems fairly logical, right? Like if we have an empty list, what's the sum of it? Nothing. That's the same as the first add we did in the last part. So that's probably fine. Otherwise, what we've got here, else mid takes on the value len list divided by 2. Okay, so we're trying to find the sort of the midpoint of our list. And then we return add 2 with the first half of the list, and add 2 with the second half of the list. Okay. While we're here, I don't particularly like that we've used the keyword list for our list variable. So I'm just actually going to go through and change that to listy. I'm not OCD or OCD. But yeah, so we're sort of going, okay, cool. Well, if we take the first half of the list and add it up, and we add it to the second half of the list and add it up, assuming our add to function works, then this should work. And so it seems like a fairly reasonable thing to do based on the last part that I was talking about, right? We're kind of assuming that this add to function works. So we go, cool, chop the list in half, add up the first half and the second half, sum them together. That seems fairly reasonable. So where are we going wrong here? Well, for starters, slice indices must be integers. Okay, so for starters, this line here is giving us a bit of beef. Because what if we have an odd length list, right? What if we got a list of length 5, say? We chop it in half, we're gonna get 2.5 here. Okay, and so we're gonna try and slice a list up to 2.5, and just to sort of see what's gonna happen here. Yep, so I hate that sound so much. 1, 2, 3, 4, 5. All right, if we try and slice that list from nothing to 2.5, Python's got beef, right? What do you mean 2.5 element? And it's pretty reasonable. So for starters, we're going to want to replace this with our integer division, right? The double divide. I think initially this tutorial was actually from back when we did Python 2. And in Python 2, single division was actually integer division. So that probably hasn't even been considered here. But basically, if we use integer division, right, we're always guaranteed to get a whole number, right? So in this case, we would have got 2. And that's fine, right? Because even if we don't cut our list directly in half, as long as we're sort of splitting it fairly evenly, or fairly consistently, we're still going to get the two chunks of the list added together, right? Like it doesn't matter if we go 0, like the first 2 things and the second 3 things, or the first 3 things and the second 2 things, anything like that, right? We're still adding everything up. So, cool. Error fixed, right? Let's run it again. Oh my, that's a lot of red. Cool, recursion error. Maximum recursion depth exceeded in comparison. And that's, whew. Okay, sweet. That's a lot of the same error message, right? So here is your main issue you'll probably encounter when you're trying to develop recursive functions. We've hit max recursion depth, right? In other words, this function has called itself so many times with the same arguments that Python's gone, enough is enough. It's time to stop. I'm cutting you off, okay? In other words, we're not reducing this sort of sample space correctly as we go, right? Because we're never consistently hitting this base case and ending our recursion. So let's actually try and step through this and break it down and see what's happening. So let's actually, what did I call it with last time? Cool, let's shorten this. And we're still gonna go forever. Yep, cool. So what did I call there? I called add to 1, 2, 3. Okay, well, our list isn't empty, so we're gonna hit this case here. So what are we gonna return? We're gonna return, well, let's think. Our mid is gonna be length of the list, integer divided by 2. Now 3 divided by 2 should give us 1, right? Because it's integer division, so we round down. 3 divided by 2 is 1.5, round down to 1. So we're gonna get add 2 of everything up until 1, i.e. just the first guy. Okay, I'm going to add that to that second half of the list from the 1th guy onwards, so 2 and 3. Okay, now what's going to happen here with add 2 and 1? Well, is our list empty? No. So we're going to come down into this section here. And I'm going to try and space this a bit so it's a bit more obvious what's happening. Okay, so now we're hitting this add 2. Now, 1 divided by 2, it's going to give us 0, right? Cool. And if we take a list from everything up until the 0th element, well, that's going to give us nothing, right? Let's just confirm over here. 1, 2, 3, right? If we take everything up to the 0th element, we get nothing, empty list. Okay. Now the second half of that thing is everything onwards from that. So that's going to give us 1. Okay. Starting to see a problem here. We called add 1 and we got something and add 1. Okay. Now add 2, 3 over here is going to split in half, right? We've got 2 things, so it's just going to split evenly. 2, oops, plus, oh, it's add 2, isn't it? Add 2, 3. Okay, so let's do this one more time just so we can sort of confirm what's happening here. Add 2 of nothing. Well, this is our base case, right? We've hit our base case. Everybody wins, right? Not quite. So this gives us a 0, which is what we wanted, right? That's good. And then we've called add 2 of 1. Now we know add 2 of 1 gives us this. Okay, so maybe it's starting to become a bit more obvious why we're going to sort of hit that max recursion, right? Because we're calling add 2 with the 1 element list, and we're getting 2 things out, and we're getting the same thing out every time as well. This guy here is just going to keep giving us itself every single time we call. And so let's sort of look at the logic behind what's happening here. We're basically saying we want to split our list in half every time until we get all empty lists. Now, inherently, sort of stepping away from the code, this doesn't even make sense, right? If we think about it, we're basically saying, cool, I want to chop up this list into the lists of size 0. Okay? That's a bit weird. It basically sounds like we're trying to divide by 0. And that's more or less what this recursion, what this add function is trying to do at the moment. It's basically just like, let's just chop up this list until all the things are so small that they're nothing. Okay? And so I've talked about recursion being, you can sort of approach it basically like magic, right? Like assume it works, go from there. But we can still step back and look at this kind of objectively. The actual things that the recursion case returns are determined by this, like what we actually return, right? So here we're returning 0. This is just returning function calls, right? So these function calls can go for as long as they want. But in the end, the only thing we can actually get out of this is 0 at the moment. So it doesn't really matter how deep our stack goes with this. The answer can only ever return 0 because that's the only actual number we're trying to give back here, right? Think about in the previous examples we looked at. I've actually cleared my file here. I probably shouldn't have done that. But in the previous examples, we had this return list 0, right? We're actually giving back elements out of the list as we go. Here we don't give anything out of the list. We're just going, cool, just return 0. So something's gone wrong here, right? We never actually get anything out of our list. And it's kind of looking like this base case is the culprit, right? Because recursively, this recursive case kind of makes sense. Chop the list in half, sum them all up, add them back. That seems fairly logical. What doesn't seem logical is trying to reduce a case to empty lists, right? Trying to chop something up until we've got nothing. It's not how division works, and it's certainly not how our recursive division is going to work. So let's rethink this. The problem is with our base case. So let's try and go back to the drawing board with the base case. Now, empty list isn't really going to work here because we're not subtracting, we're dividing our list up. So we can't divide down to 0, right? Because as we saw at the end here, when I was trying to call add2 with a length 1 list, right? If Python tries to split a length 1 list up into 2 things, it gets 2 lists, right? One that's got nothing in it and one that's got 1 thing in it. And that doesn't really help us because we've basically just added nothing. We haven't even changed the situation. So let's actually try and reconsider this case. So we don't want the empty list. Let's try and stop 1 earlier. What if we stop at the case of 1? Well, if our list is only 1 thing long, what are we going to return here? Right? There's only 1 thing in the list, so the sum of the list is that 1 thing in the list. Okay? And now at this point here, we don't really need to change our recursive logic here, right? Because our recursive logic was basically chop it in half, add it together, that sounds good. So the only thing we really need to confirm is that we can reduce consistently down to the base case, okay? Which was what the previous algorithm failed to do. It failed to get to the base case consistently. And that's why it didn't work. So let's think here. If we have a list of length 3, what can we do? We chop it in half and we get a thing of 1 length 1, and we get a list of length 2. So that's fine, we've hit our base case. What if we have a list of length 2? We chop that in half, we get 2 lists of length 1. So that's fine as well, right? And anything bigger than 3 is just going to reduce to one of those 2 cases, right? 2 or 3, like, you know, we might have to split it a whole bunch of times, but it's eventually going to get there. So this appears to be a lot more solid. So let's try running this one. And there we go. Seems to be working. As always, we don't want to be too sort of specific with our test casing. So let's try and reorder this. Still working 15. Okay. So the 2 golden rules of recursion, right? You can assume, there's 2 golden rules. Like I had something prepared. Let's just, you know, stuff you need to know about recursion, right? You can assume your recursive logic will work. You can assume your function will work in your recursive logic, provided and only provided, like if and only provided, that you can consistently reduce your input parameter down to the base case, okay? It's not straight magic, right? It's fairly magical, and it's a thing of beauty when it works. But we do have to do some of the heavy lifting ourselves, right? If you can't reduce to the base case, you can't apply recursion. It's that simple. Okay? So hopefully that's sort of added a bit of clarity here, and one of the main error cases you need to consider is yeah, am I going to reduce consistently to my base case? But I'm rambling now, so let's digress. In a computer's file system, folders contain files as well as other directories, right? So basically, you know, I open up my file explorer, and you know, I've got all these things in my Rudi folder. I've got all these folders. These folders contain files, right? And they also contain other folders. And then those folders can contain files or other folders. And you can see that the actual structure for a foldering system is actually recursive itself, right? It's folders that contain other folders. So we can apply recursion to sort of apply a search here. So we're going to write a function list files, which takes the name of a directory as input and returns all the possible files we can get from that directory, okay? A directory is just a fancy name for a folder. It sort of comes from Unix systems, Linux systems. You know, it's something Mac would apply. Windows works slightly differently, but essentially we're going to look at folders within folders. So let's think about our base case here, or our recursive case. If we're recurring through a list, or we're recurring through this folder, right? And we've kind of got 2 options. Either the thing we're looking at is a file, or it's a folder. Now, in the case that it's a file, well, we just wanted to build up a list of files that we could access, right? So if we find a file, we're kind of done, right? We go, oh, cool, that's the file. You don't need to go any deeper. So we're donezo's. So that's, whereas if it's a folder, we're going to have to go, you have to recur. So that's going to be the gist of our sort of recursive logic. But obviously, it's going to sort of be a bit more complicated than that. for this scenario here. So for starters, you can check out these hint boxes here, but essentially we're going to be using the Python's OS module, operating system module, right? Basically to give us access to folders and stuff. So what we want here is we got list files, and we want to list from this directory, right? We basically want to go, well, let's look at all the things in this directory, and if they're folders, we want to go deeper and keep recurring, right? And if they're files, we want to add them into this list we're building up, because we want to return a list at the end, right? A list of all file names that can be accessed from that directory. So for starters, let's set up that list. We're going to want to build up as we go. And then the first thing we basically got is we need to, if we chuck in a file, a folder, CSSE1001, we need to see all the things inside it. Okay. Now you can check down here, but the one we're going to be looking for is the os.listDirectory method, because that basically goes, cool, if you give me a directory, I will give you everything inside that directory as a list. I'll give you a list of that directory. Okay, so our directory was the thing we passed into the function, right? So this is the list of things, and we are going to want to look at everything inside this directory, right? Because this is going to give us back a list of all the files and folders. And so I'm just going to call this, for file, I guess is a bit confusing. I guess I could call it thing. That's a pretty awful variable name, but for now we're just going to roll with it because it could be a file or a folder, right? That's the point, is we don't know. Now you might sort of be thinking, hey Rudi, I thought the whole point of this recursion business was to not have to use for loops. And in the previous cases you would be right, okay? But let's sort of think about the difference between this case and the previous cases. When we're doing our add and our min and our second add function, we're really only working in one dimension, if that makes sense, right? We've got this one-dimensional array, right? It only extends along, like there's just like a line of elements. They're all in a line, and we sort of work through them. So that's one-dimensional. So we were sort of using our recursion to work in that level of depth. Whereas in the folder system, we've kind of got this tree, right? So there's actually sort of two directions of extension, if you think about it. A folder can have a folder within it, and that can have a folder within it, right? So that's sort of like a depth direction. But inside a folder, you can have lots of sort of sibling files, right? Where there's a file and a bunch of folders that are actually on the same level and they're within each other. So in this case, since we don't know sort of how deep our stack is going in terms of the folders within each other, that's where we're using our recursion. We're using our recursion to go in that direction, to go deeper into the folders. But to see actually all the things inside the folder, inside a single folder, and look at them all individually, we're using a for loop to sort of hit that horizontal level, if that makes sense. So wait, let me just boot up this guy again. So sort of if we go to Rudi, we can recursively go, cool, get me everything in config, get me everything in Eclipse, get me everything in Electron, right? We can recursively do one of those at a time. But to do all of them, we kind of just want to for loop over all of these guys at the start and just go, cool, recursively get me everything out of here. Next thing in the loop, recursively get me everything out of here. If that makes, hopefully that makes a bit more sense, sort of why we're kind of looping in two directions almost. At every level, we need to continue to loop, and then we need to recur deeper, and then loop, and then recur deeper. So that's why we have this for loop here. So we've got this thing that we're looping through in our directory. Now, I talked before about what our base case was going to be, but let's sort of just set this up here. Base case. And recursive case. Okay. Now, I mentioned it before, but let's sort of just reiterate. When are we going to want to finish sort of trying to go deeper into our folder system? Well, when we hit a file, right? Because if it's not a folder, if it's a file, we can't go any deeper, right? Now, the OS module, once again, has this os.path.isDirectory. Oh, and I've actually just been briefly reminded of this. In order to actually get the sort of absolute path for our object, we actually need to use one of these OS modules. So when I talk about path, right? See how here, this file here is called week11py, right? And that's what it's called locally, sort of if we're in the right folder. But its actual name is this thing here, right? We're in the C drive, users, Rudi, 1001, dank scripts, week 11, right? This is the sort of overall path of the thing, right? And so in that case, in order to actually use this thing that we get out of the directory, right? Because this thing is only going to say week 11. It's not going to have all this pizzazz on it. And so we just want to use this os.path.join method. You can go through this hint box here, sort of just to see what it's doing, right? So when we did path join with directory and assign1, so in this case, our directory was this, right? And so for Windows with assign1, it sort of just glued the two things together. That's more or less all the path joining is doing, right? It's sort of just constructing this path join for us. But we're going to want to return our, we're going to want to join our directory and our thingy, because we don't know whether our thingy is a file or a folder, right? I don't really like this thingy thing. I'm just going to go back to calling it a file. The file might be a folder as well. That's fine. We'll deal with that if it happens. But let's just call this our path, I guess. Here's the path for an actual thing. It's our directory linked, tacked on with our file, because we've sort of gone one layer deeper. So our path, right? We need to know base case is file, and our recursive case is it's a folder. So in the case of our base case being a file, how do we check that? Well, that sounds like an OS thing, and it is, right? os.path.isDirectory. So there we go. If os.path.isDirectory, and then we're going to give it our path. So if it is a directory, that means it's a folder. So I guess I should probably flip these comments around, but instead I'm just going to put if not, right? If it's not a directory, then it's a file. Otherwise, it's a folder. So let's think of what the easiest thing we could do here, right, is. So we're trying to build up this list, right? And we want to build up this list of all the files we have. So if we hit a file, well, it seems pretty straightforward, right? We should just chuck that file into our list, okay? How do we chuck stuff into a list? Append. And we're going to append our file, right? Or should we append path? Actually, no. Let's just append file. It's just so we can just see the end sort of result. Okay. Now, in the case of our recursive case, we've got a folder, right? Now let's apply that logic once again, that our list files works, and our list files gives us the list, a list of all the possible files that you can access from within a folder. Now we're sort of looking at something that we know is a folder, right? We're looking, and we know that path is a folder. Okay, so actually no, I'm going to use path here, right? And so at this point here, we go, well, how do we get? I need to get all of the things that this path can access. Well, we assume our function works, right? And so we need to go, well, I need to get all of these guys, and I need to put them into my listy, okay? So you might initially think that the sort of solution is just to append all these guys in as well. And you're very close, but that's not quite right, okay? Because if I bring up a shell here, say I've got some list, right? And I've got some other list that's, 4, 5, 6, okay? If we go x.append y, and have a look at what's in x, there's actually only 4 things in x, right? 1, 2, 3, and then a nested list, right? And that's not exactly what we wanted, right? We kind of wanted something that looked, typing, more like this. And so Python actually just has a slightly different method for that. It's in the hints on the tutorial page, like I was saying last week or the week before. Always read the hints. We give you a lot of useful stuff, but the method we're looking for is extend. So let's just typing. Well, let's just reset that. So x.extend with y, and we can see now we've got that behavior. So extend is basically a multi-append. It basically says, cool, if you give me a collection of something, I'll take all the stuff out of it and append it individually one by one to x. Okay, and we can see that that's more we want here. So we're actually just going to use extend. Okay, so looking back at the recursiveness of this, for each file in the current directory we're in, set up some sort of directory stuff so we know what we're looking at. But if the thing we're looking at is a folder, is not a folder, we know it's a file. So we wanted to build up a list of files, right? So we just chuck that into our file. There's our base case. And then recursively, we go, well, if it's a folder, get all the possible files you can access from that folder, right? Now we know that we can use our function to do that because our function works with magic, right? And we go, we'll get all of those guys and chuck them into our list. And for that, we use .extend to sort of make sure we get them in one by one. Now, so that, assuming that all works, right? we can just go at the end of the day, well, we just want our listy, right? Because we had two options, two kinds of things we can get in the top level. We can get a file, chuck it in, or we can get a folder, get all the stuff out of it, chuck it in. Okay. Now, I should probably find a folder that's got some stuff in it. So let's actually go to the dank scripts. Actually, yeah, let's just run dank scripts and see what we've got here. So if you're in Windows, you can sort of just click here, copy, paste. So I am going to call list files with this path. Now, since we're in Windows and we're using the backslashes, you'd have to double backslash these so that Python doesn't get confused with the single backslashes. Forward slashes, excuse me. And yep, cool. So let's try running that. And that didn't do anything because I didn't print it. Whoops-a-doodle. There we go. Okay, this is a bit hard to read. Let's just, for file in this list, let's print file. Let's try and make this a bit nicer. There we go. Okay, cool. So I gave it my dank scripts folder. Everyone should have a dank scripts folder. And it was basically saying, cool, so give me access to all the things. So we can see in that top level of dank scripts, we've got this class test and this week forward shoot. And we can see we got them. We got class test, week forward shoot, cool. And then we can see after that, it started to go into these folders. So week 6 has config text, Scrabble scores, and week 6, cool. And then it's gone into the week 7, gone through there, gone to the week 8, week 9, okay? So I don't have any sort of double nested folders, but since it's his recursion, right, we know it's going to keep looping and looping and looping because it's already gone one layer deeper than we started. So there's no reason why it won't keep going deeper, right? There's no sort of more complex code to look at than that. Okay. So hopefully this sort of gives you an insight on how powerful this recursive tool can be. Like I've written what here, like, I don't know, maybe 10 lines of code, and it's given me every possible file I could want from any directory. Okay, that's incredibly powerful. And recursion is super powerful in these, when we have these structures set up that are almost recursive structures themselves. And really it's pretty much the best way. I'm not going to say the only way, but it is the best way to access a structure like that. Okay, if you're getting interested in this recursion stuff, definitely think about looking at some future courses you can get into. One of my personal favorite courses, Comp 3506, Algorithms and Data Structures. There's a lot of good recursion in there. You'll do a bit more of recursive stuff, hopefully, in CSSE1002 if you keep going along the software course. But yeah, otherwise there's this final exercise here, Tower of Hanoi. I'm not going to go through it personally myself because there is this excellent YouTube video here that basically explains the gist of how to do it with recursion. It's even got the actual sort of solution in that video. So if you're struggling with this, definitely check out this video. But otherwise, the main thing is sort of trying to get your head around these simpler cases. And then there are a few more examples in the past exams. So if you need to go through and look at that to try and get your head around this. And it's a really sort of common thing people struggle with. So there's heaps of other stuff out there on YouTube and just on the internet with getting help with recursion. But hopefully this has been informative and you've managed to learn a bit about recursion. So as always, if you've got any questions, chuck them in the comments section, chuck them up on Piazza. I always try and check it out. I'll try and get back to you, particularly on this topic because I love this topic, if you hadn't noticed. But yeah, otherwise, I hope you guys had a great weekend and I will catch you all next week.